First, we're going to skip the opener since we did basically just go through some of the homework questions to address what we would have done in the opener. Good practice if you do want to come back to it, but we're just going to jump straight into the properties we're going over today. Okay, so we're adding on. Again, the tension needs to be up on the lesson that we're working on. We're going to see some of the same properties that we used last time. So might be a good idea to look back through those notes as we get to some of the homework questions. But we're going to also introduce, it's really just one new exponent or one new property here. The second one is an extension of our product raised to a power. So we've kind of seen that before. But this first one is dividing powers with the same base. This time around, I'll start with the words and then kind of explain it after. But when we divide powers with the same base, we subtract the exponents. So this is almost the opposite of if I have like x cubed times x to the fourth, where I add those exponents. Okay, now it'd be like x cubed divided by x to the fourth. I'm just going to subtract the exponents. Now, how I explain this, let's pretend I have x cubed divided by x squared. Well, if we think about what each of these means, right? X cubed and x squared. That means x times x, where x squared means x times x. And what we end up having is a bunch of x's divided by themselves. And anything divided by itself is 1. So these x's essentially divide out. And what's left over is a single x on top, which is x to the power of 1. Now, I can get to this 1 by taking the 3 minus 2. Right, 3 minus 2 gets me to that exponent of 1. So again, this whole explanation, I like to show that because sometimes you're going to forget these rules. But if you break down what the exponent itself means, you can always remember these rules. There are other examples laid out right here. I didn't print all that well, so it's kind of hard to read those. But basically saying the exact same thing, where we're going to subtract the exponents. Okay, and then the last property, and again, this is an extension from one we've already seen. It says raising a quotient to a power. A quotient is the result of a division problem. So the fact that we're just seeing quotient means that we have some division raised to an exponent. This time, to raise a quotient to a power, we're going to raise the numerator and denominator to the power and simplify. That wording isn't all that great. Basically, just like when we distribute that exponent, it's like that same rule here. So let's pretend that I have like x, let's go squared divided by 3, and we want to cube this. Okay, so this is me just explaining this. So the cubing part means this whole thing raised to the power of 3 times itself 3 times. So that'd be x squared over 3 times another x squared over 3 times another x squared over 3. Okay, and this is me multiplying now 3 fractions. So in my numerator, when I do x squared times x squared times x squared, that's the same base being multiplied, where I add those exponents. So 2 plus 2 plus 2 is 6. So I get x to the 6th. In the denominator, I have 3 times 3 times 3, which can be written as 3 cubed. Okay, so now I'm thinking about how can I get these exponents with where I started. Well, I can get there by taking this outer exponent of 3 and multiplying all the exponents by that 3. So x squared times 3 is x to the 6th. Okay, or the exponent of 2 times 3 is 6. 3 to the power of 1 times 3 gets me 3 cubed. This could even be written as x. 3 times 3 times 3 is 27. All right, and that's all the rules. So combining what we worked with on Friday with these two today, we talked about, really there's one that we're not going to get to in this class, okay, but basically all the exponent rules that we will cover in this class. So now we just got to practice. Practice is going to go very similar to what we did on Friday. Right, I'm going to do a couple. I'm going to ask that you do some. Like before, it's really important that we try these even if we're not even close to right. Okay, now, first thing I want to point out, I'm going to do number one in a really long way, where I'm going to kind of explain every little piece here. And again, eyes and ears should be up on what we're doing. First thing, when I see this 3, a cubed, b to the power of 0, none of those are. So we can think about this as 3 times a cubed times b to the power of 0 over, even with the denominator, yes, there's some multiplication signs in there, but really everything's being multiplied there. Okay, so this is a to the 4th times b to the 4th times 4 times a squared times 2 times a cubed times b squared. And if you're someone that's sitting there and you're like, oh my gosh, these exponent properties, they're really hard, I'm already confused and we're just starting, start with this. Write everything out as being multiplied. It really helps our brains not feel like any of these things are stuck together. Okay, so now, I highly recommend that we deal with the numerator and simplify it as much as possible, and the denominator separately, and then take care of this division. Okay, so the first thing in my numerator that I notice is I have a b to the power of 0. That's just 1, so I'm going to cross that off. So my simplified numerator is 3 times a cubed. In the denominator, I'm going to combine any bases that are the same. And let's start with the number. There's only one number. Actually, there's 2. 4 times 2 is 8. So in the denominator, we have an 8. Then I have a to the 4th times an a squared times an a cubed. Well, those are same base being multiplied, where I need to add those exponents. So 4 plus 2 plus 3 is 9. So that's a to the power of 9. Then for b's, I have b to the 4th and b squared. Again, those are being multiplied in that denominator. So I add the exponents to get b to the 6th. And our whole goal is to be able to write just one base, or each base, one time. Okay, so the 3 and the 8, there's really nothing we can do here. But the a cubed and a to the 9th, we can simplify that. Right? That's going to simplify if I subtract the exponents. 3 minus 9, that's negative 6. Now, when I do the subtraction, that automatically brings that term up to the numerator. Okay, so the subtraction is happening in that numerator. And I'm going to show you another kind of shortcut here of how we can skip this step. But you'll notice I have a to the negative 6, and the negative exponent now tells me to send that term back down to the denominator and make the exponent positive. So that's 3/8. This is moving, so that's a to the 6th, b to the 6th. And this is fully simplified. Okay, so another way to think about this, yes, I did 3 minus 9 to get this negative 6. But like I explained when I went over this property, I am getting 3 a's to divide out for my numerator and the denominator. So really, I am taking 3 of the a's away from the denominator as well, making this go from 9 to a 6. Okay, and you don't need to show this whole thing getting to that negative exponent. Okay, if you can just think about why are these things, why are we subtracting them? Okay, because they divide out, makes it a little bit more simple to get there. Okay, let's do number 2, and we'll just do this in a little bit quicker manner. I'm not going to write out all the multiplying. We'll just see what things can we simplify right off the bat. All right, so the numerator, there's nothing more that I can simplify there. So I'm going to leave that the exact same. So 3x to the negative 2. The denominator, I have a 3 still. Any to the power of 0 is 1. I'm going to get rid of that. This is actually a 3 times 2, which is 6. So let's change this 3 to be a 6. Then x to the negative 4 and x to the 4 is 0. But I have just this one x here, so that's just going to be a single x. Okay, so again, that came from negative 4, 1, and positive 4. Adding all those up gives me x to the power of 1. And then we still have y cubed. So now I have x to the negative 2 divided by x. So that's negative 2 minus 1. So this is 3x to the negative 3 over 6y cubed. This negative exponent is telling us to move the location of the base and then make it positive. So it's 3 divided by 6x cubed, y cubed. And now we're done. Okay, let's have everyone do let's do 4. Let's skip 3. Everyone do 4. Okay, right now all I need you to do is try. It's not need to be perfect. Come up with a good guess with your group. Simplify numerators and denominators first, and we'll check them together. And first thing that I'm doing, I'm just checking each numerator and denominator, seeing if I can simplify them separately. Numerator, there aren't any bases that I can combine. In the denominator, I can combine y to the negative 4 and y to the negative 1 by adding them. So that's how I got this 2y to the negative 5. Then I'm focused on this y to the negative 4 divided by y to the negative 5, where now I need to subtract those exponents. Again, the subtraction happens in that numerator. So it's y to the power of negative 4 minus a negative 5, which really means I'm adding 5, making that y to the power of 1. So I have 3x to the 4th, y to the power of 1, and that 2 is still in the denominator. This is as simplified as we can get. All right, questions here? Okay, let's do like one more, and then we'll pick like 3 more from this to have you all do in your groups. We'll check those, and then should bring us right about to the end of class. All right, let's see. Which one? They all look pretty ugly. Let's do 6. Okay, let's do 6. Okay. All right, first thing, again, anytime I see sum to the power of 0, that is just going to cancel out. That 0 is only being applied to that u and not to the v. Okay, the v right now has an exponent of 1. Now, before I even distribute this 2, I'm going to also simplify the numerator and denominator. And know that the order in which I do these really doesn't matter. If you're like, hey, I see this exponent of 2, I'm going to multiply all the exponents by 2, that's absolutely okay. So as we get into these properties that have, or these problems that have multiple properties, just do one thing at a time. Okay, are you simplifying the numerator or denominator? Are you going to distribute the exponent to all other exponents? Okay, as long as you're doing one thing at a time, there's not really any wrong way to start these. Okay, so I'm going to simplify numerator and denominator. So in the numerator, I just have a v. In the denominator, I have 2 times 2 is 4. Then u times u to the negative 4. I add those exponents to get u to the negative 3. And then v to the power of 3. And all this is still being squared. Now, if you want to, you could move the u to the negative 3 to the numerator right now, but you don't have to. Okay, I'm instead going to deal with taking this 2 and multiplying it to all my other exponents. So that makes this v squared divided by 4 squared times u to the negative 6 times v to the positive 6. Now I have 2 things to take care of. First thing I'm going to take care of is this negative exponent. So u to the negative 6. Remember how I originally said that negative exponents move the base or flip that base? Well, if it's in the denominator and has a negative exponent, it's going to move up to the numerator. So it just does the opposite here. So this becomes v squared u to the power of 6. And then all over 4 and v to the 6th. Well, now I have v squared divided by v to the power of 6. 2 minus 6 is negative 4. So that makes this v to the power of negative 4, u to the power of 6 over 4. And then the v to the negative 4 sends that base back down to the denominator. Yeah, good call. So that should be 16 or 4 squared. So this is u to the power of 6. And then 4 squared or 16. And then v to the power of 4. Sorry. It's hard when there's not much room. Okay, and questions there? Okay, we'll pick some that we have some more room for. All right, well, let's pick maybe not 4. We'll pick 3 that, again, I just need you to try. They don't need to be perfect, but I need you to try them. So let's start with this. Let's try 7. Let's do 9 and then 11. So 7, 9, and 11. So right now, everyone do 7, 9, and 11. If you have questions, I'll come around and check in. All right, so 7. First thing I notice, I have m to the power of 0. I'm going to cross that off. In my numerator, I'm going to distribute this negative 1, so I get n cubed times, and then that's 2 to the power of negative 1, and then times m to the power of 4, all of which being divided by n cubed. Then if I subtract these exponents on the basis of n's, 3 minus 3 is 0. Giving me n to the power of 0, that's just 1. So these essentially divide out. Giving me 2 to the power of negative 1 times m to the power of 4. The negative exponent tells me that that base is going to move. It moves to the denominator, making this m to the power of 4 divided by 2. All right, then. Number 9. Okay, right now I don't really have much simplifying I can do, so I'm going to multiply these exponents where I have this exponent raised to another exponent, making that a to the negative 1, b cubed times a to the negative 3 times b to the negative 12, still divided by a cubed and b squared. Then a to the power of negative 1 times a to the power of negative 3. If I add those exponents, that's a to the negative 4. B cubed times b to the negative 12 is b to the negative 9. And then I have a cubed times b squared in the denominator still. Thank you. Now I can subtract these exponents. Negative 4 minus 3 is a to the negative 7. Negative 9 minus 2 is b to the negative 11. Since they're both negative, they're both going to end up in the denominator. If they both end up in the denominator, the numerator is just 1. Okay, again, the explanation for that, that's 1 over a to the 7th and 1 over b. 1 times 1 in my numerator is just 1. All right, and last one, number 11, b to the power of 0 is 1. A to the negative 4 and a cubed is a to the negative 1 times b cubed divided by a to the power of 4. Now I need to subtract these exponents. Negative 1 minus 4 is a to the negative 5 times b cubed. This negative exponent tells me to send that to the denominator. So that's b cubed divided by a to the power of 5. Again, if you are not practicing these on your own and you are not doing the one thinking, these are really hard. Once you sit down and start trying them, they become easier. But you've got to try and practice these.